Hey, how's it going? Leak code 3296. Minimum number of seconds to make mountain height 0. You're given an integer mountain height denoting the height of a mountain. You're also given an integer array worker times representing the work time of workers in seconds. Worker times. Okay. The workers must work simultaneously to reduce the height of the mountain. For worker I, to decrease the mountain's height by x, it takes worker time I plus worker times I times 2 plus worker times I times x seconds. For example, to reduce the height of the mountain by 1, it takes worker times I seconds. And then to reduce the mountain by 2, it takes, so it's so height I equals worker times I times height plus 1 divided by 2, right? Like that. Alright, to reduce the height of the mountain by 2, it takes worker times I plus worker times I times 2 seconds, and so on. So this number is going to keep getting bigger, but it's not exponential. Return an integer representing the minimum number of seconds required for the workers to make the height of the mountain 0. Alright. Workers simultaneously to reduce the height of the mountain. Okay. They work simultaneously, which means we want to keep the maximum time minimal, which is different than, yeah. So it's almost like we want to choose a maximal time first and then see. You see, if you added them together, I would use a heap. But if they're working simultaneously, then it's almost like we choose the time first, right? So the minimum height of the mountain is 1. Okay, so there's always going to be 1. And then the maximum time is, well, that could be quite a bit, couldn't it? Min is 1, and the max is max worker times max mountain height times max mountain height plus 1, and then the whole thing divided by 2, and then we add 1 to that, right? Yeah, and so we calculate a time first, and then we see what each of them. But look. Well, no. This will be n log n. And so n log n 10 to the 4th, that's doable. Yeah, maybe it's not ideal, but it's doable. So let's figure this out here. So While, I don't know, max is greater than min. Assert max equals min. Yeah, and then just return max. Okay, so midpoint is going to be MA plus MI divided by 2. And then every worker is going to work simultaneously. Yeah, so we have to figure out how much each of them can do. So the deduction is going to be 0, and then we're going to say for I in worker times like this. Well, it's this here. It's worker time. So this is I. This is just like algebra here. So I times height plus 1 divided by 2. Let's do h squared plus h. And then we want it to be greater than or equal to, because this is the elapsed time, right? No, the elapsed time is m. So 2 times m then, right? Okay, but this is known. 2 times m divided by I, right? H is greater than or equal to. I mean, am I gonna have to use like a quadratic to solve this? I guess we could. Okay. What's the quadratic formula? So we're going to say h equals square root, well, negative b plus or minus. We do plus because we want the bigger one. Plus the square, well, there is no square root, so. B squared minus 4 times A is 1, and then this is C, right? So C equals this. This equals negative that. Do we want to do integer divide I, or do we want... Yeah. Times 4c divided by 2a, right? Okay. And then we would want to round that down. Height equals h. Assert. Should be -1 here. Assert h is greater than or equal to 0, and then d plus equals h. Interesting, I haven't done like a math problem like this in a while. Yeah. And then yeah, d is either going to be big enough or it's not going to be big enough. So if d is greater than mountain height, then max equals d. Do I want to set it less than? Do I want to set it less than? If d is less than mountain height, then obviously min equals it's not big enough, so min equals m plus 1. Yeah. Now, could we run into a situation where MA is not decreasing? I feel like we could. Try to think of two cases here. So if we had 1 and 2, then the midpoint would be 1, right? So in that case, MA would always go down. Now consider the alternate case, 2 and 3, which is 5 divided by 2 is 2. Okay, yeah. And we can check that. Assert m is less than mi. So that way it's always, it's always changing. Okay, now what do we do if it exactly equals mountain height? If d is greater than or equal to mountain height, yeah. Yeah, in which case we would force it lower, and then if that didn't work, then the bottom one would come up until it balanced out. Okay, yeah, that is correct. So and I think that we should have it here. Assert m is less than ma, not mi. And then assert m plus 1 is greater than mi. That way it can't get stuck in an infinite loop. And then when we, yeah, just here. All right. Int object not iterable. That is correct. Int object not iterable. Worker times. Oh. That was interesting. Int object not iterable. Iterable. Mountain height times mountain height plus 1. Ah, sweet. Will it hold? Oh, it's going kind of slow. All right. I didn't know if that was going to work, and I'm happy that it did. So I will see you later.